Good day, grade 11s. Welcome to New Dynasty Academy. Today we are continuing with mathematics. We are answering questions from the November 2023 final examination paper from Gauteng province. So the first question says here, given that k equals a root of 5 over p plus 2 plus p over 3, you need to show that k is rational if p equals 3. Now in this case, because we are told that p equals 3, so what we need to do here is just to go to our given equation, then substitute p for 3. So that is going to be k equals the root of 5 divided by our p now is 3 plus 2. So we substitute every p by 3 in this case. So you go on and simplify this. We've got 5 over 3 plus 2, which is 5. So that is going to be 5 over 5. And the square root of 5 over 5, and 5 over 5 is 1. So the square root of 1 is 1. And 3 over 3, that is also 1. So our answer is going to be 2 here. So you can see now that this is a rational because our 2 here, it is a rational number. So that is basically a rational. And that's how you prove that. Quite simple. So the next question, question 1.1.2, it says, for which value of values of p will k be real? Will k be real? Now, let's think of what is it that is going to make k to be not real. K is not going to be real if the number under the square root sign is less than 0. So we should make sure that the number under the square root sign is greater than 0. We've got 5 in our numerator, but we've got p plus 2 in our denominator. 5 is already a number that is greater than 0. So if you can make sure that our denominator is also greater than 0, then we will know which values of p will k be real. So we're going to go on and say that the number that is inside the square root sign, but only the denominator, which is p plus 2, should be greater than 0 in this case. So if p is greater than 0, you can just solve for p here. So p is going to be greater than -2, that is if you subtract 2 on both sides. So that is going to make the k value to be real if p is greater than -2. Now you can check if you substitute let's say a number that is less than -2, let's say -3. In this case, you're going to have -3. If we do it separately here, we're going to have 5 divided by, then you've got -3 plus 2. Let's see how this goes. So you've got 5 divided by -3 plus 2 is -1. So that is going to be -1. So you can see that inside the square root sign, you're going to have a negative number because your answer here is going to be -5, and that is non-real. So you can also prove that if the numbers are greater than -2, then that is going to be real. So this one, it shows you that really it don't work. But now that's how you answer that. Question 1.2 says solve for x. 1.2.1, you are given that equation here, which the first thing that you need to do in this case, you need to rewrite this equation in the standard form because you're told to correct this to 2 decimal places, which basically means that you have to use the quadratic formula. So before you can use a quadratic formula, please make sure that you write your equation in the standard form. How do you do that? You have to make sure that all the numbers are on one side of the equal sign. So that's how you do that. Then you get your values of a, b, and c. But you do remember your quadratic formula, which says what? X equals -b plus minus the square root of b squared minus 4ac, and you don't forget to divide by 2a here. Then you go on and put everything inside by substituting. So your b is -4, but remember for the negative sign, so your b is -4. Do not forget the negative, that b is -4. Don't only take the number, take the number together with its sign. Then that is plus minus the square root of -4 squared minus 4. Your a value is 3 and your c value is -2. Then do not forget by dividing by 2 multiplied by the a value, which is 3. Then from here you put everything in your calculator first with the plus sign. Remember, we've got a plus and a minus sign. So you first do it with the plus sign, then you also do it with a negative sign. So you're going to have your x values, which the first one is x equals, the positive one is 1 comma 72, or you use the negative value, then you get x being equal to negative 0 comma 39. And that's how you solve your quadratic equation to two decimal places. Very, very important, to two decimal places. Then the next question says solve for x again here, but in this case we are given an inequality. We are given an inequality which it is not written also in a standard form. So the first thing that you need to do is to make sure that you write this in a standard form. That is, you put all the terms in one side of the equal sign. So you're going to go on and say x plus 10x, then add 21 on both sides. Then you're going to have 21 on the right hand side. Then when you add 21 on the other side, they cancel each other, then you're left with 0 in this case. So once you've got that, you can go on and factorize this. We have got different ways of factorizing, but whichever that you were taught, you can use whichever way that whichever the method that you are taught to factorize. So you get the factors of the first term, which is x and x, that is x squared. Factors of 21, that is going to give us 10 as the middle term here. That is going to be 7 and 3, because you know that 7 times 3 is 21, and 7 plus 3 is 10, and they are both positive. As you can see that your quadratic has got all the positive signs. Now from here you get what we call the critical values. It's called the CVs. So you're going to say your x equals negative 7. I hope you know how to do this by now, grade 11s, and your x will be equals negative 3 in this case. Therefore, you represent this graphically. Some of us will use number lines, some of us will use the graph. I'm a fan of a graph anyway, so you can also go on and use a number line. You can see that our coefficient of a here is positive, so it means you've got a nice smiling parabola here. And what you do is that you put the smaller value on the left hand side, and our smaller value between negative 3 and negative 7, that is negative 7, and then a negative 3 is going to be the bigger value in this case. And then your solution is up there. You don't have to show that, but anyway, that's how you do that. Then you can write your nice inequality. Since we have got our inequality sign as greater than, it means you're going to use the or equality. So you say that x value, as you can see here, is going to be less than negative 7, or your x value is going to be greater than negative 3. Remember, if your inequality sign is greater than, which means it is positive, you always use what? You always use or. And then your x value basically is going to be between is going to be less than the smaller value, between the two roots, and it's going to be, x is going to be greater than the bigger one between the two. And that's how you write that, with x being greater than or less than the smaller and the bigger value. Now in this case, you can leave your answer in, I mean, this is how you can write your answer. You can just use this as it is here, but if you are told another method that you can use, you can go on and use the method that you are told to use in your different schools. The next question, we are solving for x again, but in this case these are sets, which for us to be able to solve this, we are hindered by the set sign here. So the first thing that you need to do is to remove the set sign. And how do we do that? We need to square both sides. So we're going to go on and rewrite this, and you know that you need to square both sides. And why do you square both sides? Because you want to remove the square root. So the square root and the square, they are going to cancel. You're going to be left with x minus 5 on the left hand side. And then in this case, remember, if you've got AB raised to the power n, that is going to be simplified to a to the power n and b to the power n. So this is the situation that we have here. We've got 2 multiplied by root of x to the power 2. So don't forget that you need to distribute the n to both of those numbers inside the brackets. So that is going to be 2 to the power 2, which is 4, and the square root and the square, they're going to cancel, then you're going to be left with x. So that's what you have there. So you've got nice trinomial, which means here you need to simplify by factorizing. So you're going to subtract 4x on both sides, then you're going to have negative 4x on the left hand side, minus 5, and then the 4x's are going to cancel on the right hand side, then you're left with 0. So in this case, we've got the nice quadratic, which we can just factorize here. This one is simple because our 5 here is a prime number and the factors of 5 are 5 and 1. So you can just go on and put them there, 5 and 1. Now on the sign, remember your 5 is negative, it's negative 5. So how do you get a negative sign? By multiplying. You get a negative sign by multiplying two signs that are different, a positive and a negative. So the question is, now since I know that I'm going to have a negative and a positive sign, where do I put which sign? Then you go to your middle term. Your middle term is negative, so it means then that the bigger factor is going to be negative, and it means the 1 is going to be positive. That happens if the coefficient of x squared is not greater than 1. So you can see that the coefficient of x squared is 1. So hence I did it as simple as that in this case. So you can go on and get your roots, that is x equals 5, or your x equals negative 1. And that's how you do that. But now in this case, because you are dealing with sets, you need to check also that which of the two solution is valid and which one is not valid, which in this case, as I can see here, the negative 1 is not going to be valid, because if you substitute negative 1 back into the equation, the left hand side is not going to be equal to the right hand side. So in this case, it means your negative 1 is not going to be valid. So you can say that this one is not valid. You can just write an A here to show that it is not valid, and that's how you do that. Then the next question, we're solving for x again. In this case, these are exponential equations, and as you can see, we've got two terms. You've got the first term and the next term, because they're separated by a plus sign. So what you need to do here is to first isolate the compound exponent. So how do you do that? You're going to reverse law number 1 of the exponents, because here the exponents are already added. Then you distribute them just like that. So you're going to have 3 to the power x and 3 to the power x to 3 to the power 1. Plus, you also do the same thing here, 3 to the power x, then 3 to the power 1. Now your exponents are no longer in a compound form. Then the right hand side, please leave it as it is, 10 over 9. Then work out your left hand side. So since you've got two terms here, you can check, do you have a common factor? Yes, we do have the common factor, which is 3 to the power x. So you're going to go on and do what? Take it out as the common factor. So remember, when you take it out as a common factor, you need to go back to each term and divide each term by the common factor. So when you divide the first term by the common factor, 3 to the power x and 3 to the power x are going to cancel. Then you're going to be left with 3 to the power 1, which is just 3. And again, on the next one, divide by the common factor. Then 3 to the power x is going to cancel 3 to the power x. Then you're going to be left with 3 to the power negative 1, which we can nicely write this 1 over 3. I hope you know where does the 1 over 3 comes from. If you do not know that, if you have got any number raised to the negative exponent, you can, let's say to the exponent 3 in this case, remember you can just change that to 1 over 2 to the power with a positive exponent. So that's how we write exponents to fractional form. So furthermore, we need to simplify what is inside the brackets. So how do you simplify that? You've got a whole number plus a fraction. So what you can do is that you multiply the whole number with the denominator of the fraction, then you add to the numerator. How do I do that? You say 3 multiplied by 3, that is going to be 9. Then you add 1, that is going to be 10, and you divide by the same denominator, which is 3. So my answer here is going to be 10 divided by 3, then that is equals to 10 divided by 9. Now since I'm solving for x, it means I have to remove the 10 over 3. So how the hell do I do that? How do I do that? I'm going to multiply by the reciprocal of 10 over 3 because I have to remove it and it is a fraction. So I'm going to use what? The reciprocal, which is 3 over 10. So since I multiplied by that on the left hand side, I'm going to go on and multiply also on the right hand side because I do not want to change my equation. So 3 is going to cancel 3 in this case, 10 is going to cancel 10 in that case. So I'm going to be left with 3 to the power x, which is the aim anyway. The aim was to ask for to be left with this power in the left hand side. So on the right hand side, your 10 and 10 are going to cancel. The 10 and 10 are going to cancel, and 3 to itself goes once, into 9 it goes 3 times. So I've got 1 in the numerator and I'm left with 3 in the denominator, and that's how you can write that. Then we can reverse things in this case. So since I've got 3 to the power, 1 over 3, so I can write that as 3 to the power negative 1. I believe you know all these things by now. You should be able to do these things by now. So since the bases are the same, therefore the exponents are equal. So our x is equals to negative 1. That's how you simply do that. Now this question, it says given that x plus y equals 2 and y plus 1 equals negative 3 divided by x minus 1. Then the first question says solve x and y. So it means we have to do that simultaneously. We have to solve x and y simultaneously because we've got two unknowns in this case. So how do we do this simultaneous equation? You are given two equations. So you normally look at those two equations. If you are given a linear equation, you use the linear equation to create the third equation. So in this case, it means we're going to have two equations that are given to us. So we're going to label them as equation number 1, and the other one, we're going to label that as equation number 2. Then we're going to go on and formulate our third equation from the linear equation. So you can make whichever variable the subject of the formula. So since we can see that both x and y have got variables, have got coefficients 1, so we can just decide which one do we make the subject of the formula. So I'm going to go on and use what? We can use x, we can use y. Let me use y as the subject of the formula. So I'm going to say my y equals, subtract x on both sides or transpose x, then I'm going to have 2 minus x. So that is going to be my third equation. That is equation number 3. Then I'm going to go on and do what? And now I'm going to substitute. So I write here, I'm going to sub equation 3 into equation 2. Then I proceed. So in equation 2, wherever I see y, I put 2 minus x. So the first term is y here, I'm going to put 2 minus x. The first term in the second equation, that is 2 minus x plus 1 equals negative 3 divided by x minus 1. So simplifying this, we've got 2 plus 1, which is 3. So we're going to have 3 minus x minus, equals negative 3 over x minus 1. So the next thing that we need to do here, you can see that we've got x minus 1 in our denominator, so it hinders us to be able to solve this equation. So what we can do here, we multiply each term by x minus 1 so that we can remove this x minus 1 in our denominator. So we're going to go on and multiply the left hand side with x minus 1 and also multiply the right hand side with x minus 1. So nicely we can just put everything in brackets. Therefore I can just remove the multiplication sign since everything is inside the brackets. So I'm going to here FOIL x times 3. I'm going to have 3x, then x multiplied by negative x is going to give me negative x squared. Then negative 1 times 3 is negative 3. Negative 1 times negative x, that is going to give me positive x. Then equals, what's going to happen on the right hand side, the x minus 1 and x minus 1 are going to cancel. Then I'm going to be left with negative 3. So in this case I can just group the like terms. I've got 3x plus x here, which is going to give me 4x, and I've got negative x squared. Then you take the other 3 on the right hand side, then they're going to cancel. You can see that if you take the other 3, let me just write this step. so that you don't get confused. The other three on the right hand side, I'm going to take it to the right hand side, left hand side, I mean, so that they can cancel. Then you are left with what? 4x minus x squared equals 0. So you can see here I've got two terms, but what is good about them is that they both have got x's. So it means you can take x as the common factor. Then remember, when you take out the common factor, you go onto the term and divide. So you divide 4x by x, then you are left with x. Then minus, we divide x squared by x, you are left with x. Then that is equals 0. So in this case, you've got two factors. So you say that your first factor x is equals to 0, or your second factor 4 minus x equals 0. Then you can transpose x, then you're going to be left with 4 equals x, which means x is equals to 4. Now that is the first part of calculating x values. Then you go on and substitute x values into equation 1. So the next thing is you say substitute x into equation 1. So you go to equation 1, or you can also even use equation 3 in this case, since the equation 3 is the simplified form of equation number 1. So let us say equation 3 in this case. So you're going to say your y equals your 2, subtract the first x value, which is 0. So y equals to 2 subtract 0, which is 2, and then you go on and do the same with the next yx value, that is 2 subtract 4, and your y is going to be equals to negative 2. So here you've got your two values, negative 2 and 2. Then answering the next question, question 1.3.2. Let's do it here along the side. Let's use a different color. 1.3.2. It says hence or otherwise determine the value of that given expression there, 1 over x plus 1 over y. Now in this case, you need to check if you're going to work with numbers that are valid, meaning that remember that you cannot divide by 0. So check where the x and y are equal to 0, so that you don't use those values. So you can see that the first value of x was x equals 0, and we used that with the y value equals 2. So we cannot use those ones. So we can only use, let me circle this one. You're going to use this one and this one here. We're going to substitute them. So we're going to take our equation 1 over x plus 1 over y. Then we use those values that I've circled there. So that is going to be equals to 1 over 4 plus 1 over our y here is negative 2. So you can go on and just use a calculator. In this case, 1 over 4 minus 1 over 2, that is going to be a quarter minus a negative half. It's going to be a negative quarter anyway. So that is negative 1 over 4. And that's how you simply do that. I hope you do understand that question. Question 1.4 says, given 2mx squared minus m minus 2x plus m plus 1 equals 0, where m is not equal to 0, determine the values of m for which the equation has real roots. This is the nature of roots questions. So what we need to do here, we need to determine our discriminant. But before we do that, let us first find out what are the values of a, b, and c, because that is what you need for your discriminant. So you go back to the given equation. We look for the coefficients. First of all, we need to get the coefficients of x squared and the coefficient of x and whatever that is remaining. So in this case, the coefficient of x squared you can see is 2m, and the coefficient of x squared is a. So our a value is going to be equals to 2m. Now where do you get b? B is the coefficient of x, and you can see that the coefficient of x is negative into m minus 2. So don't forget to take the negative sign also. Negative into m minus 2, and you see value is anything that is left, so which is m plus 1. That is your c value. Now using the discriminant, you all know the discriminant equation. That is, the discriminant is equals to b squared minus 4ac. So we're going to go on and substitute the values of a, b, and c. So your b here, I'm going to write b. This is b. B is negative into m minus 2. This is my b, and this b has to be squared. And that's how you do that. Minus 4. The a value is 2m. And the c value is m plus 1. Yes, and remember this grade 11s. If you've got, let's say, negative b, then you square negative b. Remember, when you square a negative number, it becomes positive. So that is going to be positive b. So here we've got negative m into m minus 2. Remember, we treat m minus 2 as 110 because it is inside the bracket. So we're squaring a negative m minus 2. So we can just rewrite this as what? As positive, because when you square a negative number, it becomes positive. So it was negative m minus 2. So because it was negative, we're squaring it, then it becomes positive. I hope you do understand it. I hope you do understand it. Then you multiply here. You can see here we have to multiply here and there at the same time. So that is negative 4 times 2m, which is negative 8m multiplied by m, and that is going to be what? Negative 8m squared. And again, you have to go on and multiply this and that, right? So you're going to have what here? Negative 4 multiplied by 2m, which is negative 8m multiplied by 1, and that remains negative 8m. And we can be consistent with colors. So that is negative 8m. That's what we have there. So here you can just FOIL this out. I hope you know how to do that by now. So you can quickly say what? M squared minus 4m, grade 11s. You know how to do this by now. Plus 4 minus 8m squared minus 8m. Let us look for the like terms. This is the step where you look for the like terms. We have got m squared here. As you can see, you've got m squared and you've got 8 squared. Then we've got what? 4m there, and we've got negative 8m there. So let us work out the like. Let's do it here so that it becomes a bit neat. M squared minus 8m squared, that is going to give us negative 7m squared. Negative m squared minus m, that is going to give us negative 12m, and for it's on its own, then we put it there. That's what we have there. So this is our discriminant. This is our discriminant, which we can multiply its term by negative sign and get the positive sign. But anyway, let's leave our discriminant in this way. I want to show you something. Grade 11s, I want to show you something. That is our discriminant. So remember that we are looking what? We are looking for real roots. Now for real roots, you can simply write this here. You say for real roots, your discriminant, it's greater or equals to 0. That is very, very important. So our discriminant is this. This is our discriminant now. The whole of this equation here, it is our discriminant. So we're going to go on and say our negative 7 m squared minus 12m plus 4. This should be greater or equals to 0, right? Now remember that we still need to factorize this so that we can get the critical values. But now look at this. Our leading term, it has got what? A negative sign here. So for us to be able to factorize this, let us make sure that our leading term has got a positive sign. So how do we do that? We multiply its term here by a negative 1. So after multiplying by negative 1, that is the first one, is going to be positive 7m, because negative times negative is positive. And again here, negative times negative is positive, so we're going to have 12m in this case, and we've got going to get here negative 4. And remember that when you divide or multiply by a negative sign, the inequality sign has to change. So our inequality sign, which is greater or equals to, is going to change to be less than or equals to 0. and that's what we have now. So from there we can just factorize this. Please do not forget that when you multiply or divide by a negative sign, the inequality sign changes. Now how do we deal with this? Fortunately, the factors of 7 here is 7 and 1, so you're going to have what? 7 m and m, and for us to get 12 here, let's do it quickly here. We've got 7m and m, and the factors of 4 are 2 and 2. So remember, you have to multiply here. 7m times 2, that is going to give us 14m, and 2 times m, that is going to give us what? 2m. And our interest is what? On the middle term, which is 12. So for us to get 12 here, it must be 14m minus 2m. So you see that your negative sign is next to the m, so it means your 2 here has to be negative. And since the 14m is positive, it means then that this has to be positive, because you get these signs by multiplying. So a positive 7m multiplied by positive 2, it is going to give us a positive 14m. Now a m and multiply by a negative 2 is going to give us what? A negative 2m. So that's how you're going to write your vectors. So that is going to be 7 minus 2 and then m plus 2 in this case. Now since our inequality sign is less than, it means your x value is going to be in between the terms, your roots here. So you're going to have x value in between less than or equals to. This one has to face the same direction. So it's always greater than the smaller value between the two here. And the smaller values you can see here, you're going to have what? M equals to negative 2. So you're going to have negative 2 here. And the other one is going to be a positive 7 over 2. Which I know very well where does this, I know you know where does this come from. And that is how you're going to write your answer. And that's how you do that, because the question says determine the values of m for which the equation will have real roots, and those are the values of m where the equation will have real roots. I hope you do understand that, but I think you need to rewatch this video so that you are confident when answering questions like this, so that you understand very well what is really happening here. So the next question says you're still determining the values of m for which the equation has two real roots within opposite that have got two opposite signs. So it should be two real roots that are opposite in signs if m is less than 0. So in this case, for roots to have opposite signs, it means then that what we remember is that, remember your quadratic your equation, it has got plus c at the end. So the c value must be positive for you to have the roots with opposite signs. So you always have to make sure that for this question to be answered here, you're going to say that your c value here, it must be positive, and that is greater than 0 in this case. So what is our c value? Remember, it was m plus 1. So our m plus 1 here is going to be greater than 0. So you're going to rewrite that as m plus 1 should be greater than 0, because that is our c value. So simplifying that, you have to subtract 1 on both sides. Therefore, your m will be equals to, greater than negative 1. So that is the case here. But now for us to have opposite signs, you can see that m is greater than minus 1. So for us to have opposite signs here, it means your m, you see that is greater than minus 1. So you're going to say that your m should be greater than negative 1, but that is going to be for one sign. And for the other sign, your m should be also be what? Less than 0 in this case. So between these values, that's when you're going to have two roots that are opposite in signs, and I hope you do understand that.